Hi guys, welcome back. For this chapter, I will teach you about methods for describing sets of data. As we learned from last video, there are two types of data. First, quantitative data. Second, and qualitative data. And now we're gonna start with qualitative data. Before we dig it deeper, first we have to know what is the class frequency, class relative frequency, and class percentage. First, class. Class is a categories of the data. Because in qualitative data, we cannot measure it on the numerical scale. So we can classify as a categories. So class is a category of the data. Category. Second, class frequency. The class frequency is a number of observations in the dataset falling into the particular class. So, in an easier way, class frequency is just the number of response in each category. For example, from 10 participants, I will write it as n equal to 10. From the participants that choose red as their favorite color, it's gonna be red equal to, in this case is 1, for example. So the class frequency for the class red is 1. The third one is class relative frequency. The class relative frequency is just to use the class frequency divided by the total number, which is n. So it's going to be class frequency divided by n. In this case, it's going to be 1 over 10. So the class relative frequency of red is 1 over 10. The last one is class percentage. The class percentage is just the class relative frequency multiplied by 100. In this case is 1 over 10 multiplied by 100. So it's equal to 10%. So the class percentage of red is 10%. Let's move on. Okay. The summary table is just to list the categories and number of elements in categories to make it easier to look at. For example here, so if we want to find a class relative frequency of red, we just need to use 1 divided by 10. If you want to find class relative frequency for blue, we just have to use 3 over 10. For green is 4 over 10. For black is 2 over 10. So 10 is n, is total. And if we want to find a class percentage, we just need to use class relative frequency multiplied by 100. Okay. The last part of qualitative data is a chart. So the first one is pie chart. The pie chart is shows the breakdown of the total quantity into categories. It's useful for showing relative differences. The angle size of the pie chart equal to 360 degrees multiplied by class percentage CP. Okay. For example, class percentage of red is 10%. It's 10%. So the angle size of red is gonna be 360 multiplied by 10% equal to 36 degrees. So in this case, the red is approximately like this. This is the angle for the red. Okay, let's move on to the next one, which is bar chart. The bar chart is the chart that represents class frequency, class relative frequency, or class percentage. Also, so the height of the chart is gonna represent all either these three. And the horizontal line is gonna be the class. Like A here, the class frequency is 3. B is 4, C is 6, D is 2, E is 4, like this. The last one is the Pareto diagram. The Pareto diagram is gonna be same like bar chart, but the class and the height will be ordered in the descending order. As you can see, the highest one is on the left side, and the lowest one is on the right side. Everything is gonna be similar to bar chart. It's gonna represent class frequency, class relative frequency, and class percentage. The height gonna be represent either these three, and the horizontal line gonna represent the class. Okay, so for the next part is gonna be quantitative data. The quantitative data elements is gonna be similar to qualitative data, that we have class frequency, class relative frequency, class percentage, and class. So, but the chart is gonna be different. For the first one is dot plot. The dot plot is to represent the class frequency of each numerical scale. For example, here is going to be the minimum, and here is going to be the maximum. And the dot on the numerical scale, which is here, which is here, 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 is gonna be the frequency of each numerical scale. To read this chart, it's gonna be like this: min, minimum, 7, 7, 7, 7, 8, 8, 8.5, 8.5. 9999 because we have 4 9 here. 9.2 and 10.5 and then max. The reason that we don't have to read the dot over here, over here, over here, over here, over here, because we don't know that what are the exact number of those number. This is just the disadvantage of this chart. So let's move to the second one. Is stem and leaf display. The stem and leaf display is to represent the frequency of the numerical scale, like last one. But to read this one, it's going to be like this: 2 1 2 5 2 5 2 7. So on this line, it's going to be 21 25 25 27. And this line is going to be 30 and 32. And this one is 41 43 46. So the value that we can read from the stem and leaf display is gonna be 21 25 25 27 30 32 41 43 and 46. And the last chart is histogram. The histogram is gonna be like the bar chart, but the horizontal line is not represent the class but the range of numerical scale. And the vertical line is represent percentage, relative frequency, and frequency, because here we don't have a class. As you can see, they are touching each other. And to read this chart, we can divide like this. Class. This one is just to make it easier. I'm gonna write class here. And frequency here. So the first one is 1 2 2. I mean this one, 1 2 2. This bar, oh sorry, too big. This bar, 1 2 2 2 2 3 and 3 2 4. So in 1 2 2 class we have 2 number falling between 1 and 2. And 2 to 3 we have 4. 3 to 4 we have 3. So how do we know that 2 3 is falling in which class? 2 3. So to prevent the confusion, we can write the class in this way: 1 less than or equal to x less than 2. This is the first class, second class, third class. Okay, this is the first class. The second class, to replace this one, is 2 less than or equal x less than 3. And the last one is 3 less than or equal x and less than or equal 4. So we're gonna include 4. So 2 gonna gonna be in the second class, and 3 is gonna be in the third class of the chart. So let's move on to the next one. So the last one for today is numerical measures of central tendency. The central tendency is a measure that identifies the center of a dataset. In this part, we're gonna use three statistics. Measurement is mean, median, and mode. Mean is the average of the data. Average. To find the average is to sum all the data and divide it by n. For a sample, the sample mean, we will write like this, x bar, to represent it. And for population, is like this. It's called mu. The next one is median. Median is the middle value when the data points are arranged in ascending or descending order. For example, 1, 2, 3, 4, 5. The median is 3 because it in the middle. Because it's at the middle. But if you have an even number of n, like 1, 2, 3, 4, 5, 6, the median is gonna be 3 plus 4 divided by 2, which is 3.5. The median of this number, the median of these data is 3.5. Next one is mode. Mode is the value that appears most frequently in the dataset. For example, 1, 1, 2, 3, 3, 3, 4, 5, 6, 6. So the mode is going to be 3 because it's appear the most frequently. It's 3. The last part is the skewed. The skewed is just the shape of the curve that describe how the data are distributed. I can write at a red, median is red, and mean is blue. The symmetric tell us that mean and median are equal. So it's going to be at the middle of the curve. Let's say it's equal. Okay. And the left skewed show us that mean is less than median. Mean is less than median. So the curve is going to be like this. And the last part is right skewed. The right skewed is the opposite of left skewed. So it's going to tell us that the mean is more than median. More than median. So the mean is gonna be like this, and the median is gonna be like this. It's not about the height now, it's about the horizontal axis. Okay, that pretty much it guys for this part. The next video gonna be the same chapter but another part of this chapter. See you in the next video.